All right. So what I'd like to do is to ask our four panelists to sit up front, and they'll come up one at a time to give their talk. So please come up front. So while people are assembling up front, I want to debug something that I hope will not come up now that I've talked about it, which is the question of what is AI? That's an extremely annoying question because it just leads to endless discussions, which if you're in a bar and it's late, maybe it's fine, but not for this conference. And so let me say it in a nutshell. Andy Beam, who's one of my colleagues who's now at the School of Public Health, and I wrote an article in JAMA where we basically said, AI is typically what computers can't do today. So AI was chess before we could have computers that could compute chess. AI was retinopathy recognition before computers can do it. So that's not a particularly useful definition, but that's the way it is. And so now we're talking about, when we talk about AI, we talk about data-driven pattern recognition to enable better diagnosis and prognoses. And this has been particularly successful in image recognition in medicine. But broadly, in this JAMA article, we point out the following two-dimensional graph. On one dimension, the x-axis is the amount of data, so going into literally petabytes worth of data. And on the y-axis, how much the computer can work independently. And so the Framingham Heart Risk Score is a data-driven algorithm that had a lot of human oversight. So it's low on the machine learning spectrum. And things like AlphaGo, where the computer program played itself to learn how to play Go better than any human being in the world, has very little human involvement. So just accept that machine learning AI is a spectrum, and let's not revisit that topic. So we have an amazing panel today, and I'm going to actually not introduce them because I hope that they'll introduce themselves. But I will introduce the topics that I talked about with this group. And they're a smart, feisty group, so they will not actually follow exactly the framing I gave them, but I want you to know the framing I gave them, which was purposefully edgy, and which they told me afterwards, as we discussed it, how it was not quite on the mark, but I want you to know where they came from. So I actually gave them a few questions to think about. Is there an argument for paternalism with regard to AI and healthcare? Should the healthcare system assume responsibility and oversight for AI behavior, or is it the Wild West? What can reduce the dangers of differential performance of AI for different socioeconomic and ethnic populations? And finally, what have we learned from the massive use of online biomedical data by consumers about health literacy? And so I'm watching John Zittrain furiously type, and I have no idea what that's about. Hopefully he's... You'll get it after the panel. Okay, excellent. So who's going to go on first? I just realized we did not do the... Andy.
Yes. It's probably the order of the slides.
Yes.
Yep. So it is me.
It is you.
Great.
Would you like to come up here and talk?
Yeah, that'd be
Please
great.
do. So here we have Andy Korovos from Electro Labs, who will tell you much more about her in a much more articulate way than I could. Thank you, Andy.
Hey everyone, I'm Andy. I am the CEO of Electro Labs, and I will give you a little bit more of my background. We very firmly only have 5 minutes, so I'm going to drop a bunch of things, and you can ask me for the slide deck afterwards. Also, if you have questions, you can shoot me a note on Twitter, and I'll send you a note afterwards. Okay, so my background, CEO of Electra. I'm currently a member at the Harvard-MIT Center for Regulatory Sciences and formerly served as an entrepreneur in residence at the FDA. The FDA is considering how to handle machine learning and AI and thinking through software as a medical device and what that can look like. And they've been hiring a number of different software engineers and others to look at that. I served as a software engineer at Kili Interactive, which is creating a video game for pediatric ADHD. I won't talk about that today, but if anyone told you video games would rot your brain, there's probably going to be an FDA-cleared one soon. And yeah, vindication. I was also in private equity and served as a consultant. So I'll start I spend a lot of my time thinking about connected medical devices, which have a lot of different types of data. This is one of my favorite pieces around where does your data go? And so won't get into this too much, but effectively this CPAP machine, which pretty much most people use, which is a ResMed machine, was sending the data to the patient, to the doctor, to the supplier of the machine, and also to the insurer. And there's really nobody who's seeing and regulating where that data actually gets sent right now. And a lot of that data can have pretty meaningful impacts. And much of that data is also not regulated through traditional policies like HIPAA and others that we have. So even things that seem relatively benign, like whether or not I've changed my name, actually indicates quite a lot. So most likely that means I just got married. So that means I'll probably be expensive and have a pregnancy soon. Or I had a divorce as a woman, and so that would also run up my medical bills. So as we think about who gets what types of data can have pretty meaningful impacts, even if it's not healthcare data. Where I start getting really interested is around digital specimens. So we have pretty strong protections around biospecimens, blood, genomic data, and others, but we don't have good regulations today around all of this data that comes up in our digital phenotype. And so what Eric Perkalis and I recently wrote is that we think that our digital specimens should be treated with the same rigor, care, and attention afforded to physical medical specimens. But who would be responsible? We'll dive into this probably into the panel. There's a massive gray space. It's not the FDA today. FTC is currently under-resourced. There's a number of different people who are touching different parts of digital data, but no one right now. So we're faced with a new set of conundrums. Imagine you want to use some sort of wearable in your study. Your IRB has approved 3 measurements. It's not like the wearable's not going to collect the other 10 if it's measuring multiple. You can't really turn off a lot of the data collection that many of these tools are doing. But you can anonymize it, right? Like, this data is not really identifiable. How many people here think you could de-identify your genome? Probably not, because your genome is unique to you. Same with most of the biospecimens that are coming off a lot of wearables and sensors. So I am uniquely identifiable with 30 seconds of walk data. At a certain amount of time, with the mass amounts of data that we have, you really can't, quote, de-identify it anymore. I try not to use the term AI because all AIs are just algorithms. And when I think about what an AI is, drugs have side effects, algorithms do too. Some of those side effects might not always be as apparent to us as we start using them. There's some pretty famous testing that Facebook ran around the news feed and how people responded to different things in their news feed. I think a lot of what we see today in tech, and especially A/B testing, is effectively different types of unconsented human testing. And as that post-market and pre-market starts merging a lot more, it's really unclear when you're in the experiment or when you're not. So patriarchy, can we actually develop better tools and have safer algorithms? One argument I would say is, why not just treat an AI like a drug? So you develop it in the same sort of way. You have a population, you have inclusion-exclusion criteria, they have different types of mechanisms of action. Particularly if you think about digital therapeutics, those are all AIs. They have a certain type of mechanism of action. You can do public reporting. Is there an argument with what we've learned in healthcare to actually train and look at them in the same way that we look at and consider drugs? So as we start moving towards personalized medicine, can we really get that separately from a system that is effectively 1984 and surveillance? My argument is probably not. So in that world, we probably can't think about data ownership anymore, and it's much more about data rights and governance and who gets access to what data at what times. Now, given that we really don't have any agency overseeing it, the only thing that's generally left for us is something that might come up, which is this lovely end user license agreement. How many people have read one? Really? Oh, look at all of you. Good. So one thing I think is going to be interesting and a lot of people think about is like, how can we have a version of consent that is much more consented, and like, what does that social contract look like given that we can't really de-identify anything? Okay, how many people here know what DEF CON is? Raise your hand really high. Oh my goodness. Okay, there's a lot of you. We'll talk about a little bit about this. All these tools are connected devices. Anything that's connected to the internet has vulnerabilities. This has a whole new slew of issues that we now have to consider. Within DEF CON, there are 30 villages. It is one of the biggest underground hacking conferences in the world. 30,000 hackers descend on Vegas. You do not bring your phone or smartphone or anything when you go there. There is a whole group that is hacking on medical devices. And they've done a lot of work around pacemakers, blood infusion pumps, and they are now working with the FDA. And the FDA has recently launched a new program called #WeHeartHackers, not kidding. And you can go to wehearthackers.org, and they're starting to work with security researchers who can secure a lot of the devices that are collecting this data. Okay, so to end, as a lot of these tools start augmenting or perhaps replacing the role of clinicians in certain instances, clinicians take a Hippocratic oath to do no harm. Should the software engineers and device manufacturers and people implementing these tools also take the Hippocratic oath? Argument is probably yes. And so many people from the DEF CON community put together a Hippocratic oath for connected medical devices. Similar thoughts are, as a clinician, you have a society that you can join to train and have ethical debates and how you actually can develop in your field. What is the Society for those who practice in the digital era of medicine? This just launched a week or two ago. You can take a photo, you can join it if you're interested. It's called the Digital Medicine Society, DIME, and it is working with a lot of these issues. So we're hitting an inflection point, and we'll talk a lot more about that today. Thank you.
Excellent, and the pace I love. So our next panelist will tell us a lot about what I was telling you about bias. So she'll introduce herself again far better than I could. Please, Khadija.
Thank you. Okay. Good morning, everyone. My name is Khadija Ferryman. I am a medical anthropologist and researcher at the Data and Society Research Institute in New York. I, for this past year, have also been an Open Science Fellow at the Mozilla Foundation. And as of this coming fall, I will be the Industry Assistant Professor of Ethics and Engineering at NYU's Tandon School of Engineering. Yay. Hey, thanks. So for those of you who may not be familiar with medical anthropology, what that is, it is a subfield of the discipline that focuses on trying to understand the multiple factors that influence health and well-being, very sort of broadly understood. So these can be looking at factors anywhere from cultural beliefs about health and illness to really trying to understand the multitude of social, economic, and political factors that shape biomedical research as well as the practice of biomedicine. And I have been using this lens, this medical anthropology lens, for the past few years to try to understand this emerging and developing field of precision medicine. And this is a report that I authored with a co-author of mine at Data and Society that came out last year. And as I said, we stepped into this field trying to understand from a critical medical anthropological perspective this emerging field of precision medicine, right? So what are the social, cultural, ethical implications of this field? And particularly in this report, what we wanted to do was try to understand the potential for bias and discriminatory impacts of precision medicine. And this report is available online at the Data and Society website, so I won't go too much into our actual results. But what I will tell you is that our findings were sort of in two buckets. So primarily where if our overall research question was, what is the potential for bias and discriminatory outcomes in precision medicine? What we found is that there is a potential for bias in the data sets and sort of the data inputs for precision medicine. And again, we're talking about multiple kinds of data, from genomics to electronic health records to Fitbits and these other kinds of data sources that we've all been talking about this morning, as well as the potential for bias and discriminatory outcomes once these precision medicine tools are developed and deployed in society, right? So we kind of characterize these two findings as bias in data inputs and bias in sort of the outputs and the tools. And part of the motivation for taking this kind of approach to precision medicine, like I said, comes from this anthropological background, but it also comes from what I was seeing in some places and not seeing when looking at algorithms, AI in the health field. And what I was seeing was that in other fields, there's already ample evidence that the use of big data, AI, and algorithms can have a disproportionately negative impact on groups that already are impacted by injustices such as racism and sexism. So this is a headline from a ProPublica piece that came out actually now maybe about 2 years ago that examined how risk scoring algorithms were discriminating against Black defendants. And this is another book that many of you may be familiar with that again details some of the vulnerabilities in algorithms. And what we are seeing now is that in the medical field or in the use of using AI in medicine, that these systems are vulnerable to some of the very same pitfalls. So this is a headline from a study that was published in The Atlantic, I believe, last year, again, showing the limitations for an AI that's used to diagnose skin cancer for people with darker skin. And then most recently, a colleague of mine, Marzia Ghassemi, and her team, formerly at MIT, now at the University of Toronto, did a study showing that when you look at EHR using natural language processing and other tools to look at EHR clinical notes in psychiatry, that the mental conditions or mental health is documented differently in these notes between groups like women and people of color, and that the predictions, the predictive tools that are built using these notes actually have, again, different performance depending on groups. So the accuracy of an ICU mortality, it was less accurate for women, for example, and again, it's because of the bias that was sort of embedded in these clinical notes that were used to build these tools. So using AI has the potential to advance medical insights through the collection and analysis of large volumes and types of health data. However, we must keep our focus on the potential for these technologies to exacerbate and extend existing unfair outcomes. It's essential to continually examine the data themselves for visible and embedded biases, and the embedded biases are the ones that are very key. Even the last example the last two examples that I showed, the AI for skin cancer, it was very clear that part of why that tool didn't work well, or the main reason why that tool didn't work well, is because something like 1% of the samples that were used in the database were people of darker skin, right? So that seems like a pretty clear bias. But the EHR example that I showed is one where the bias is a little bit more embedded. You really have to read those notes clearly and see that clinicians are documenting and talking about mental illness in different ways depending on what that patient in front of them looks like. And so untangling that kind of bias is more difficult, but I would argue even more important. So we have to think about how these biases can have ripple effects on everyone, especially those who are the most vulnerable and marginalized. So I do hope that if we keep our focus on asking these kinds of questions, so sorry, I'm just losing the last part of my notes. Oh no. Sorry. Okay. Essentially what I was going to say was, and I should also include, I did write an editorial in the Cancer Letter last year with a physician, Robert Wynn, called AI Can Entrench Health Disparities, and we lay out sort of 3 ways, a framework for how AI can address health disparities. And essentially, if we continue to ask questions about data biases, data inputs, as well as think about our healthcare system today. Our healthcare system is plagued by health disparities. No one can deny that. That don't just have to do with the biological signature or the physiology of the people that come into the system, as the clinicians out here know, right? A majority of illness is actually caused by social issues and not so much on biology, right? So I feel like if we continue to ask these questions and contextualize these AI tools with our disparities in our healthcare system, our larger social disparities, we will get to a future of health that is better for all of us. And I look forward to talking with you more about these issues. Thank you.
Thank you. All right. As part of my pattern, I will actually not introduce the individual by name, except to say Jim. But here's the thing. Because he's super characteristically modest, I'll tell you that Jim is responsible for most of the healthcare data that's accessed by consumers worldwide. You'll see why.
It's because I have so many healthcare problems. Actually, this is sort of old home week for me. I started my graduate work in the Harvard Biolabs in the late 1970s, but it took me forever to get a PhD because the computer science department thought I did biology department thought I did computer science. You wouldn't mix those things, and it takes a long time for Harvard professors to say they're wrong. I was one of the founders of NCBI in 1988. We started with 12 people and no projects. Today, we're serving about 5.5 million users a day. Our website runs at about 7,000 web hits a second. We serve people from all over the world. We distribute more than 100 terabytes of data every single day. What was one of the surprising things to me was the shape of this curve, which is number of users. That cycle that you see is an annual cycle with a dip for Christmas and New Year's and Thanksgiving on there. We can tell when the Japanese go to lunch and when the English go home from work, speaking of stealing data. But what we didn't expect, we expected this curve to level out because there's only so many molecular biologists in the world, and we didn't think there'd get to be that many more. Instead, we see it accelerating. And that has two major causes. One major cause is the drive of molecular data into many other fields of research, not just medicine, but agriculture, chemical engineering, environment, everything. And the other is the advent of the internet, and which didn't exist when we started, and the expectation of more and more people that they can directly find data themselves. And that also really changed what we saw as our mission. Because originally our idea was we would collect the information, we'd build new resources, we'd make that available to people, but we wouldn't really be spending time building user interfaces because that would be all the people distributing it out. In the internet-enabled world, they come straight to us. And so we find ourselves having to sort of engineer the interfaces to this real time for people from a broad range of backgrounds. Some researching incredibly important problems to themselves, like the health of their children. And that proves to be very challenging because we actually are at the National Library of Medicine, so we are a public library. We're not a healthcare agency. We're actually not even a quality review panel. Quality is established by the scientific community, the clinical community. It's not established by us. And frankly, no scientist in the world would thank the library or the federal government for deciding what's correct and what's not correct, what's the best and what's the worst. You want us to represent everything that's gone through sort of legitimate channels and make it available to you, but not scored by us. And so there's a contradiction in terms here of how do we provide an unbiased view of the available data and at the same time, when individuals come to us, provide the best information to those people without violating that trust or inserting our personal opinions in this. Is there a clicker up here to?
I want to be old school.
Oh, old school, all right. I got shown a clicker earlier, so it's hard to do because at this point, coming from 0 resources, we now have tens or almost 100 different resources. We provide PubMed and PubMed Central, the book site. That's used by about 4 million users a day. We provide molecular databases such as Gene, GenBank, protein databases, structure databases, blast searches, PubChem, clinical trials databases. The Registry of Clinical Trials of the United States is there. That's about 300,000 daily users. And then specialized data sets like dbGaP or the Short Read Archive or ClinVar that a lot of people use still by 15,000 daily researchers. The challenge for us is that every day we're processing submissions from more than 3,000 different groups and individuals from all kinds of different types of information with different structures, with different ways that people evaluate quality of that information. And so as much as possible, we have to automate it. As much as possible, we have to sort of learn what the conventions of that field is and what people accept as a reasonable level of quality. And I raise this because it's sort of like paying your taxes. Whenever people submit data to us, they typically complain about how difficult it is and how we get in their way and we don't appreciate their creativity and stuff. But when they use the databases, they complain that it's not standardized, that there isn't a high level of quality control, that we don't go back and curate the database. So balancing, and in fact, we've had people who have sent us email arguing both sides of that at different points in their career. I should have a little rogues gallery of those people. So this is a constant balancing act, and this is a constantly moving target for kind of what's good enough. And it is in only rare cases possible to go back and fix old stuff. Because at one level, it represents the scientific record. It's the GenBank sequence, which was published at a certain time with certain annotation that support the assertion in this paper. At another point, we realize it's the wrong organism. So what do we do? And I'm not going to talk about that because I don't have time, but I am going to give one example. This is from PubMed. This article is still in PubMed. This is the Nature article that started the anti-vaxxer movement. So it has now been determined fraudulent. There is a retraction notice on it, but I would say it took 12 years before that was retracted. And furthermore, the retraction notice doesn't tell you why it was retracted. It doesn't tell you it was fraudulent. It points to all the letters and things that went behind it, so you have to go read all of those. And even those are pretty carefully couched, as all you scientists know, saying, well, it wasn't collected the best way, this information. In fact, if you go behind the scenes and read about it, people were actually paid off here, or they had interest in the companies that were involved in this project. It was definitely fraud, but I can't say that in PubMed. This is a personal opinion of mine, not an expression of the federal government or anyone who works for them. But this is still in here. And so if you are someone concerned about autism in your child and you're searching PubMed, you can find this article. So what can we do as a library? Well, one thing we can do is this. We know that in the internet era, nobody looks below the fold. So we have to try to answer your question and give you the top 6 right answers for you. And we also know that most queries made on PubMed consist of between 1 and 3 terms. So we don't really have a whole lot to go on. In this case, what we've done, this is actually PubMed Labs. This is the new version of PubMed that we will be, you can see it now, but it'll be rolled out this fall. This uses a relevance-weighted retrieval. So it's using machine learning techniques to sort of tune the answers and try to play a number of factors off in sort of what's the best answer to an uncouched query like this, which is taking advantage of how scientists regulate themselves, which is we uprank review articles, and we uprank highly cited review articles. We uprank them by date, but we're weighing all those factors, and then we've tuned it, because there's no real absolute right answer here, we've tuned it with a learning to rank approach to machine learning, and then also tested it on our users with A/B comparisons, where sort of like Google, you don't know you're being tested. We've route about 5% of the traffic off to something new. We see if people do better on that, and if they do, then that becomes the default. We've left in the date-sorted search, because that's what people researching a particular area of interest to them tend to choose. You want to see the latest article in your field, but if you do, the relevance is now the default. It didn't used to be the default. It is now, because so many of our users are now general public, just coming in from Google and places like that. And you can see in the query here, the query was just vaccine autism. The top-ranked article is on vaccine myths, published in a fairly reputable journal, and would be sort of the first thing that you'd want somebody to look at who's like this. There's other tools and facets on the left that allow you to select other high-quality results. I'll just end by saying that we have to figure out how to do this on everything. So we do stuff like this on GenBank, on ClinVar, on clinical trials registry, but I don't have time to tell you about it. Thank you.
Thank you. And again, I will not introduce him by much, except to say Jonathan is a deep thinker about how technology and the internet hits our society and the law, and I look forward to hearing from him.
Thank you, Zach, for that fulsome introduction. I got to say, I think Matt might, and the work he's doing and talked about this morning, gives me some real hope. Because when I first heard his motto, and I wrote it down carefully, the definition of precision medicine, better living through data chemistry, I was somewhat skeptical. But then I realized he added something to it, and perhaps should formally add something to it, which is through data chemistry and reason. Because if you're just focused on the data, most of the systems racing through public and private means to make sense of it are simply spitting out answers. And what makes Medicanron so different is the fact that it's attempting to use some form of logic. And I think, Matt, you may have been a little too modest in failing to highlight that difference from the rest of the world. The rest of the world is picking up a tradition that is quite venerable in coming up with new medicines for treatment, which is basically pump some animal through with a new substance, see if it dies. If it doesn't, see if it gets better. And if it gets better, try it with humans. So I was thinking about that because here's Nuvigil, the successor to Provigil, the drug that's supposed to keep you awake. And I don't know if you ever read the inserts that come with drugs, with prescription drugs, the little cellophane origami thing that you unfold, and you're like, this is going to be interesting. And then it turns out to be a very 2-point font with all sorts of stuff. And then there's from 8th grade chemistry, the molecular composition of the thing you're about to take. Good to know. Patient support there. And then in the case of Nuvigil, this is the thing that really caught my eye. Mechanism of action. The mechanisms through which armanafil promotes wakefulness is unknown. All right, well, I'm ready to stay awake now. I don't even need to take the medicine. A lot of medicines are this way because it was a form of basically A/B testing that produced the useful association. And Matt made reference to this, the sort of trial and error kind of way of doing things. Now, I'm still going to take it, I think, if I need to stay awake, because aspirin discovered 1897, mechanism of action figured out 1995 at Princeton. So it took a while. This gap is what I call intellectual debt. Machine learning systems, as commonly deployed, offer us answers without reasons, and when they work, we would be nuts not to use them immediately. But when we do that, we are incurring an intellectual debt that collectively we promise will pay back later when we figure out how the thing actually works, rather than it's just a magic pill and it does what it does. Now, there's that famous article, Software is Eating the World. Machine learning is now eating the world. Where isn't it? I think of machine learning kind of as asbestos. It's not something you're buying retail. It just sort of comes along with something. It turns out that it's all over the place, even though at no point did you explicitly install it somewhere. And it has possibly some latent bad effects that you might regret later after it's too hard to yank it all out. So this kind of machine learning is the sort of thing that just loves associations, and it eats databases and data sets like those Jim was talking about for breakfast, lunch, and dinner, and then it comes up with associations that sometimes can go awry. Here on a recent iPhone, a hurricane alert for Hawaii, an immediate following push notification, different Pokemon can be appearing in parks around you. Great time to explore your local park. A circumstance not anticipated by the data set that fed the Pokemon's blandishments to you in the app. Or this from like 10-15 years ago on Amazon UK, the official LEGO creator activity book, Perfect Partner, American Jihad, the terrorists living among us today. This is the kind of bias that Khadija was talking about, and for which you're like, I'm just going to back slowly away from the LEGO activity book. I never used it, that kind of thing. When you at base are only making correlations, statistical correlations, no matter how tightly you set your p-value, you're going to get some spurious ones. Former student of mine maintains this site of spurious correlations. Here, the suicides by hanging, strangulation, and suffocation correlates very tightly with the number of lawyers in North Carolina. Now, it's true, we don't know the causal direction yet, which is causing which. Here's another favorite one. Letters in the winning words of the Scripps National Spelling Bee, very nicely correlated with the number of people killed by venomous spiders. So just a message to Scripps for next year's spelling bee, for the love of God, please just make it a short word. And I think, though, this is my favorite. It's the potential opium production in Afghanistan charted against a silhouette of Mount Everest. And if you just turn your binoculars slightly to the right, you know what opium production is going to be in the following year. These are the kinds of things that can creep into systems that just chew up data. They make really tight correlations, but because there's so much data, we don't really know what's going on. We don't have the reason component that the kind of system Matt is talking about does in fact provide. This also leads to certain vulnerabilities that some people in this room, including Zach and Sam Finlayson and Andrew Beam, have been working on, where, for instance, this is a picture of a cat. Google's Inception algorithm, which eats cat pictures for breakfast, lunch, and dinner, very nicely identifies it as a tabby cat, maybe a tiger cat, little bit Egyptian cat, and then, no pun intended, the long tail of carton and plastic bag. Very low probability, but still in the running, dark horse candidate. You can change just a few pixels of this cat. See if you notice the difference. Here's the new cat, and now Google is 100% confident that it's guacamole. Now, this is a frontline system installed and used wholesale and retail across the world for image recognition, and it's able to be tricked like that. That's a problem. When you peel up these systems trained by machine-supervised learning, you get weird stuff underneath. Here's somebody experimenting with the near miraculous, hold up your iPhone camera, you can see some words, run the Google Translate app, it translates them on the screen like that. Somebody with too much time on their hands asked it to translate from Maori, dog, 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 and the resulting English translation, doomsday clock is 3 minutes at 12. It's increasingly approaching the end times and Jesus' return. Okay, so now let's put this into the world of medicine. How do you feel taking stuff where the thing just spits out 100% confidence that guacamole is what you need to cure what ails you? Now, Andy came up with another point, that she was talking about the way in which life events can end up affecting your insurance rates. And sure enough, here's Admiral Insurance's experiment in which they let you hook up your social media accounts for a possible discount. They found, through lots of statistical correlation, that those writing in short, concrete sentences, using lists and arranging to meet friends at a set time and place, rather than just tonight, got into fewer car accidents, and therefore their rates would go down. That was, in fact, before Facebook decided to pull it for privacy concerns. When Facebook thinks you have a privacy problem, you have a serious privacy problem. But these are the kinds of associations that mean precision medicine of the future isn't just going to predict stuff on the basis of who knows what. That, to me, is what the title of this should be in PubMed. Turned out we can predict if you're going to die, and we're not sure why. And so that could be news you could use, Magic 8-Ball, that basically works. But you could also see using this stuff not just to assign medicine to you, but to make a cascade of lifestyle recommendations that may not make a whole lot of sense, but the statistical correlations say this is what you do. Do you live in an odd or even-numbered house on a street? Time to move to an even-numbered one, because the data says you'll be healthier that way. These are the sorts of associations that can lead you on a cargo cult scramble to change your life with no medicine even required, with no understanding of what's happening. So as we more and more forge things like this advertisement for insurance that through A/B testing means no one would predict it, but somehow that makes you want insurance from these people, we cultivate a kind of Promethean knowledge that is the fish without the fishing line. If you do this, it will work. But there is no understanding of why until we try to pay off the debt. One hopes that various academic departments could use these associations in ways to set agendas for research and say, cool, let's figure out what the hell is going on here. Another future is one in which everybody in each department is just running a different machine learning model that spits out answers specific to their zone. So just as the old VCR of past days shows us the blinking 12 but plays the tape and we're not sure how it works or even how to set the clock, it's evocative of kind of Clarke's third law, which is any sufficiently advanced technology is indistinguishable from magic. He was actually taking that from Lee Brackett earlier, who wrote Witchcraft to the Ignorant, Simple Science to the Learned. The easy story to say is, yes, the patients don't get it, but we do. Intellectual debt raises the prospect that even we in the health field won't actually understand what's going on. Matt's keynote emphasized to me that humanity is a stateless system. It has to keep relearning what it even discovered before, and that's what databases like Jim's are for, but they're growing so quickly you can't just read them. He offers some opportunity to ingest them and to spit out relationships that are worthy now of the kind of study that so far only humans can do. I think of a graph of humanity. On the right, you have the nerds. All right, they're going to figure stuff out. They don't have to worry about things. The Luddites who say, I don't worry about technology. There's no asbestos in my house. And in the middle is kind of everybody else. And they need the kind of leadership and empowerment. They need to become truly the focus of the system. And making sure that we understand our intellectual debt, when we strategically incur it, and when we're going to pay it, to me is central to making that the case. Thank you.
So thank you very much. I think it's time to start trying to repay our intellectual debt. And so I would really enjoy asking questions of this panel, but you can ask the questions if you wish first. But if I don't, not you always ask questions, get down. Adrian.
What can be
Get
said,
closer to the microphone, I can't hear you.
what can be said about human-in-the-loop AI relative to this intellectual debt or reasoning issues that have come up?
I find the human-in-the-loop approach very promising. As I understand it, it's the idea of trying to not just set it and forget it, but put somebody working almost collaboratively with the AI to figure stuff out. Some of the worries about it are that you can set it, not forget it, and then just rubber stamp it, because you want to be the human in the loop that gainsays the machine that seems to be right all the time. It's almost a flavor of Newcomb's paradox. And then it's just, you become, in the words of one paper, a moral crumple zone. You just become the person that when something goes wrong, it's like, aha, there's a human in the loop. That's the one. And then it's sort of Shirley Jackson's The Lottery, a metaphor I haven't had a chance to use since 9th grade. There are some who have said that maybe society in the loop is actually the nifty metaphor to make, that as we design these systems, as we review the data, it's important not just to have kind of a night watch person sitting adjacent to it, but rather a genuine conversation and work on what's the data going in, what's the model it's producing, and how often does that model need to be tweaked. There's a neat thing about technical debt in machine learning systems that really deserves more exploration.
Khadija, could you,
Yeah,
perfect, sorry.
I was going to add to that as well. So two things. The moral crumple zone is from a paper written by my colleague at Data and Society, Madeline Ellish, so it's a great paper to look up if you haven't read it. But the other thing about humans in the loop, the problem with having a human in the loop is if that human in the loop holds the same biases that the technical system shows them. So for example, research has shown that clinicians rate black people's pain in a different way than other people. And so if there is some kind of technological device that, spits out something saying that, black people have a lower pain threshold or something like that, if you have that exist, if you are a human and you're evaluating that, but you hold that same bias, having that human there to review it is not necessarily going to offer that kind of solution. So the human in the loop solution has some upsides, but again, depending on what kind of issue that we're looking at, and if that human has the same biases and perceptions, then having that human in the loop is not necessarily going to be a corrective factor.
Andy, you want to comment on that? No, she doesn't.
I think it was well stated. Yeah.
All right, all right.
I'd like to comment on that. So we have a number of examples. For example, in ClinVar, trying to determine the pathogenicity of a variant is very hard to determine because you actually only know the pathogenicity much later than the testing. And so originally the notion was people were submitting data with their calls, and then we would score how consistent those were and have a panel of experts come in and review the calls. And what we discovered was they were incredibly inconsistent, which was appalling to the panel of experts whose field this was. And so they worked very carefully together with the different labs making the submissions, and now they're consistent, much more consistent, but we have no evidence that they're actually more correct. So it depends on the motivation of the human bias, if you will, when you introduce them to those sorts of things.
Okay, I actually now have a comment. I think one thing that the tech world did, I think that poisoned everybody, is this whole idea around neutral platforms. And there really are no neutral platforms. So the decision, whether or not you have a human in the loop or not, like there's a set of values that that society or that system has. And I think the most important thing is for us to understand what those values are and be more public about them rather than like pretending like it's a neutral system.
That's great. Zuckerberg just texted me that he'll give us a full grant to shut down this conference. All right.
Great. So, fabulous panel. I have questions for all four of you. I'll save them. But Jonathan, you were the last to speak, so I'll give you mine.
Sorry, introduce yourself.
Paul Bleicher from Optum Labs. Thank you, Zach. Of late, especially with the Book of Why by Judea Pearl, the concept of causality, I think, is really coming to the fore, and that's essentially the opposite side of the talk you were giving, which is there actually is a formal logic that's been developed by Judea Pearl and many others coming from epidemiology and mathematics and philosophy and others that are applicable, and he says are absolutely essential for addressing the issues you've raised. What do you think the prospects are of applying formal logic in that sense of causality to addressing these issues?
I think it's a good tool in a toolkit. I think that being clear about what relationships we're claiming under time's arrow happen is good. The absence of that is worse when you're trying to figure something out using the scientific method. I think at some point you hit some philosophical bedrock where the issue is not empirical or even logical formalism, but rather what we choose to say the word cause means, especially when multiple causes happen. And if multiple causes happen, figuring out what is the meaningful, the relevant cause starts to be a statement as much about human psychology or about agency and moral responsibility as it does about literally which thing is causing which. I also think there are times when it might be okay to use proxies if you can't get to the underlying cause. There is huge danger there. There's huge potential for bias. We see ways in which by trying to exclude something from a system, if there are other proxies for it, it'll end up taking it into account even though you don't want it to. But there are other instances in which it might be somehow the number, the street number of your house really is material to a better outcome to you because it's the south side versus the north side of the street and the sun goes a certain way, and then once you get that, you get it. But even without that explanation, using what you clearly know to be a proxy might turn out to be helpful. Figuring out when it's helpful and when it's pernicious is part of what makes this so challenging.
And I would add, you could read several volumes of the Talmud just arguing when you have multiple causal agents, who actually causes it.
I actually put those into a machine learning system and it answered it.
Seriously?
No.
That would have been cool. And I want to point out that I am gullible, or maybe an optimist. But I want to point out that there's also another issue, Paul, wherever you went, is that there's also time pressure. And so when you're Matt Might and you have a kid, sometimes you don't have the luxury of figuring out whether cigarette smoking actually causes cancer. You just have to act.
Hello,
And identify yourself.
my name is David Platt. I teach computer science across the river. I'm the author of the book, Why Software Sucks. And the forthcoming sequel, Why Software Still Sucks. But my question to you is, the MBTA here, the Local Transportation Authority, perhaps that not somebody you want to emulate just right now these days, but they have something very interesting in their in their technology department. They've taken all of their schedules and all of their data and they've put it up publicly with RESTful APIs. So instead of writing a scheduling app, they've opened it up to anybody at all who wants to write any kind of scheduling app. And so anybody who wants to write one that concentrates on bicycles or whatever can do that and have these great things. And so you were talking about your user interface challenges. I was wondering if that was just opening up the API to anybody who wants to write a search algorithm or whatever, is an approach you ever considered?
Well, yes, there are open APIs to all this data. Also, all the data is downloadable, or almost all the data is downloadable, with described schemas and formats and update patterns. And again, like I said, we sort of did that on the basis that we want other people to do all this stuff, and actually other people do all sorts of other things. The issue we have with having that appear to be on our website is everybody wants it on our website. And as, again, sort of as a federal agency, we're supposed to be even-handed and fair. And so we've also taken, I'm a firm believer that software does suck, particularly in academic software.
Thanks.
It lacks the profit motive, that's all. There's no incentive to get it better. They don't make more money if they get it better.
Well, we all need more money for sure, but we've taken a number of pieces of academic software over the years and tried to implement it. We actually even took software from Hewlett-Packard at one point, which was their development software, and it was we ended up basically having to rewrite it. And, and the reason is because most academic software runs for you and a few of your friends. For us, it's running at 7,000 hits a second. And so, you know, little flaws, memory leaks, all that sort of stuff just kills us. So at this point, we encourage people to use the APIs, download the data, be creative, and, you know, blow us out of the water.
Thank you.
All right. Please identify yourself.
My name is Cheryl Brown at Mass General Hospital. I did not publish a book or data or anything. I just have a layman's question, and I hope it's not antithetical to this discussion. I want to know, is there any hope of using this platform of precision medicine for food as medicine, preventive maintenance, when it comes to allergies or intolerances, food as medicine?
So Jim, I'll start with you, just because you just insulted academic software. I imagine you have a lot of visitors to NCBI that want to look around the medicinal properties of different foods. How have you dealt with that?
Well, not well, I would say, because it is sort of buried in the scientific literature, and in the broader literature, there's a lot of really strong biases and sort of fan clubs. There's no doubt in my mind that nutrition is critical to health. In fact, I was sort of thinking and listening to Matt's talk about all the ways of sort of delving into all these issues. There's much lower hanging fruit than that in improving healthcare in the United States. For example, feed people good food would be one thing that would actually cure a lot more people and a lot more disease than any of this stuff we're doing here, I would say. Just the quality of delivery of healthcare in community hospitals. You know, I've just had a daughter-in-law who did a diagnostic journey for more than a year and a half through various community hospitals, and it turned out she had C. difficile.
Wow.
And they just didn't manage to culture it at any of these places, so she was in misery for a year and a half. It took going to UCLA Medical Center, and that was the diagnosis. So so I don't have a magic cure to that. I don't have a good answer to your question, but I think it's relevant.
I think one that might be interesting is, and I'm a little hesitant to bring it up here because I don't do like microbiome. I'm sure someone here knows it better than I do. But like part of the reason, from my understanding, that we don't have a perfect diet is we all absorb and use food differently. And so what AI is really good for is identifying different patterns. We all have a series of different set of bacteria in our gut. So some people might spike with blood sugar with white rice, some people don't, some spike with ice cream, some don't. And so one of the things that people are looking at is if you sequence your gut, can you actually identify based on your set of bacteria how you might have a different type of nutritional needs than somebody else. And I think that's like not a human problem because there's so many different types that you would need a tool like an algorithm to be able to identify it.
These are good points, and whoever, I don't know where she went, brought up the food, I think raises a great point, because unfortunately there's so many dollars associated with food that our own institutions here at Harvard have been guilty to several, I hate to use the term, fake news bulletins over the last 30 years. Margarine, better than butter. Sugar, not fat. Eggs, bad. Turns out none of it's true. And so it gets hard when you have some vested interests that are pushing a narrative, even when we have far fewer facts and far less autonomous computational engines. Yes, and identify yourself.
Yes, I'm Faraz Yashar. I'm an undergraduate research intern at the Harvard Institute of Biomedical Informatics. And one of my questions, the broad statement is that a lot of the AI systems that we see that are in existence rely heavily on labeled data by people in, foreign countries. So basically they've mechanical turked out all of the human information and the human reasoning in order to create and produce good AIs. And you see this in self-driving cars, and the way that they're starting to basically do labeling and those types of predictive tasks. Matt, Mike, what you're working on sounds like you're using a cohort of undergraduates to basically do that work for you. And if this is having good labels is an important part of artificial intelligence, how do you all see that the funding could come about, or how could we actually create some type of consortium to produce good quality data that could actually be fed into the algorithms that we're trying to produce?
So, Andy, why don't you start with that? Because I know that one of the things that you were doing in under one of your many hats was benchmarking a number of digital health algorithms, which presumably are linked to outcomes, labels. How does one pay for that, support for that, look at the quality?
Yeah, I was looking at it slightly differently. So I think I think it's so hard to answer this in broad strokes, like the Twitter answer for it. But I think a lot of it is like quality control for data sets. I mean, anybody who's worked with data, like you don't even know what the errors are until you're kind of like playing around with it. So I'm sure there's like a lot of opportunity around government grants to create like bigger, better data sets. I mean, that's what the All of Us program is supposed to do, and others. I think, at least for what we're trying to do with Electra, is we're looking at all the different types of digital biomarkers that people can collect, like heart rate, blood pressure, all these different types of biospecimens that you can use. And part of it is you want to make sure that the data is accurate, but you also need to make sure that it's usable. And if you're using, especially if you're going to have systems that are constantly flowing data, like you're not just training the model one time, you're going to be collecting specimens over long periods of time, you have to make sure that the system's resilient to attacks, and also making sure that you're not sharing and leaking out data to parties that you don't want. So accuracy is only one part of what we look at for a system, and also usability and attacks and data leakage.
And I can.
So go ahead, Khadija, please.
I was just going to add to that. So, as I mentioned, our report, Fairness and Precision Medicine, our findings are in sort of two main buckets: bias and outcomes, and potential for bias and discrimination in the deployment of precision medicine. And in the first set of findings, bias in data sets, we include, there's an example in the report from a computer scientist who we interviewed, who's now at Google, who works on developing AI tools for health, and he brings up this specific example of labeling and the problems with labeling. And one of the things that he sort of walks us through, that the example that we include in the text, is he says, EHR data is quite problematic. And if we want to find out, if we want to look at an EHR and say, is someone diabetic? You have to look, you can't look in just one field, right? You have to look across the whole record. Lab results, notes, all different sorts of fields. There isn't one place in the EHR that says yes or no, this patient is diabetic, right? So the example that he tells us that, and he says, so when we were developing a tool, because there isn't one way, there are different lab results, we had to sort of figure out how to make this decision, how to begin to label the data and make these decisions, because that's what labeling really is, right? It's making decisions about what the data mean. And he said, we brought in clinicians to help us with that labeling process, because we are not clinicians, we're computer scientists, right? But he said was, well, often the clinicians themselves didn't agree about, for example, which lab test result meant unequivocally that this person was diabetic or not. Is it, using this kind of medication for this long? So he said, well, because the clinicians didn't agree, then we actually just didn't ask the clinicians anymore, and then we made our own decisions about what the labels meant. So it's a really important, and then there's also the other example, like you said, of being labeled by people, these very low-wage workers working on Mechanical Turk. So I think this is another great example to really highlight again where some of the limitations are when you're thinking about even the process of getting the data labeled. And again, when I talked with this software engineer, I said, well, could you bring the clinicians back? And he did point to some examples of some companies where they do hire clinicians and have them go through record by record to understand the data and label it and have that labeled data being fed into EHRs. But you can imagine the cost of that, right? To hire clinicians to go through record by record. So the cost is really also an issue as well.
So just as we've been developing this, I think the question you raised, which was a great starting point, was just what happens when the labels are wrong? It's like it's a blue chair and somebody hung a thing that said red on it because they were in a hurry or they didn't quite get it. But then as we went on, we were identifying deeper and deeper problems, which is how do you know what a chartreuse chair is? I don't know. And we're going to differ on that, much less like a healthy chair or an unhealthy chair. And then there's a deeper problem under that, which is how do you choose the classification scheme itself? When you're beholding something you're trying to represent in data, what are, as Andy was originally saying, what are the right things to measure from it? Partly it's just defined by, well, what measurement tools do you have? I guess that's what we'll measure, but that's a weird way to define what you're measuring. And it turns out that what you measure often depends on what you're trying to accomplish in the world. And especially as transfer learning is seen as such a big deal in AI. I trained this thing up to do Go, and now it's going to tell me whether we should go to war with another country because it learned Go. Like, that's transfer learning. It's really cool. It may turn out that classifications that worked well for one purpose will completely bonk in the new one, which for those who are custodians of repositories and just trying to say, here's a data set, it's not maybe neutral, but it's got classifications and labels, there it is. It's too easy for somebody to take one off the rack and use it even for purposes that were never anticipated. There's a data set nutrition label project and also a so-called positionality project coming out of something called the Assembly Program, bkmla.org, each of which is trying to address these issues at all stages of the data gathering, labeling, and ontology process.
So I'd actually love to comment on this.
Please.
Because ontologies are the bane of my existence, frankly.
That's a good book like Why Software Sucks.
Right.
Ontologies are the bane of my existence.
Because it's a bunch of ill-defined terms assigned by people who didn't look at all the data. And then it's a standard. And I'll give one example of, I think, a positive direction that can be taken here. So I don't want to only be negative about this, which is to find an objective way to generate your labels eventually. So one example is the organism name of a sequence submitted to GenBank, because it's critical that the organism name be correct, because the discovery of whether, say, two proteins that are similar to each other, whether that is surprisingly functionally conserved, is only if they're distant organisms. If they're both primates, then it's not that exciting. If it's a primate and a bacteria, it's a big deal. So we put a lot of effort into getting organism names correct from the submitter at the time. We have a whole set of taxonomists who worry about this. We talk to all the nomenclature committees. But as sequencing progressed, and as more and more bacterial genomes were sequenced, we started to realize how inconsistent this was. If you compare the sequences of things with the same organism name, there's all sorts of, spread and confusion. So working with the stock centers and with the nomenclature committees, we tried to collect the genomes or partial genomes from the strain that the name was originally assigned to, because that's what that name means taxonomically. It was this strain from this. And it turns out, by the way, due to contamination and multiple passage, even thinking you have that strain is not always true, because when we started to sequence them, they weren't all the same. But we could sort of trace it back to the ancestral one, and then we built algorithms based on those for the distance from that, which we would still consider the same species or strain name, and that varies by organism also, and by the community that uses it and the biology of the organism. It's not one answer. And then just in the last couple of years, we've got the International Bacterial Nomenclature Committee to agree that sequence trumps the name now. And so now it's reversed. Now if you submit a bacterial genome to GenBank, we tell you what organism it is. You can argue with us, but we think we know better than you. And that proves to be true, and it's also one of the few things that we've actually gone back through the database and corrected.
This is like Revenge of the Librarians. They tell you
Right, exactly.
the book.
Because we have the backing of the community that specializes in this, that this should trump it. And if you can find GenBank records which will have two labels now, original name and sort of correct name, because this is, you know, such a critical thing.
There's a Soviet Union joke in there, but never mind.
But my point is that I think the important thing is to seek out those kinds of things, not have mechanical Turks, not having humans trying to put labels on things, but, you know, are you diabetic because your blood glucose is above some measurable level?
Of course, that is going completely against the business plan of most AI companies, which say,
right,
I'm buying a bunch of labels, electronic health record system is a label, I'll buy this set of labels, and then we move forward. Please identify yourself.
Yes, hi. Jenny Barba, venture partner at BioVentures Investors. We invest in digital health and medtech. One of our portfolio companies has the ability to do machine learning on a global level with patient samples. And we are coming across issues like CFIUS. And I would love to get your, and for those who don't know, CFIUS is the review of foreign investment in U.S. companies and technology, specifically if there's data, patient data, things like that, because the concern is that foreign investors are going to take our data. Would love to get your, and one of the topics of this panel was policy.
Yeah.
So I would love to get your specific involvement in policy. What are you or your company or your groups working on in a policy arena? Because I think we need to be aware of some of the hot issues that you're facing on the policy level.
Okay, I'm going to do something.
And I know it's a big question.
Okay, that's a big question, and so I'll do my particularly blunt/nasty self, and I'm going to pare it down to one of your sub-questions was, what about with the labels are international, and are there regulatory or conceptual issues and Khadija, cultural/bias issues about labels that were learned in China, applied here, data applied, genomes acquired here, applied to China. Anybody want to comment on this the transnational
We
nature?
might want to give some context for people who don't know at least my understanding, and others correct me. So like one example was there's a dating app that has certain sexual preferences, and when they had international investment, they're worried about blackmail. So if you knew certain like senior politicians and you knew their preferences, could you use that as blackmail against them? Another example was if you're sequencing genomes, it's a lot cheaper possibly in China, and if you send the sequences over there, is China keeping a copy possibly of those sequences when you're doing it?
That's definitely a good version of it.
Okay.
Yeah, and so for example, this one company, if we are international in all different countries, we actually can't send patient data back to the US headquarters, and we can't send US data outside.
Well, so one flavor of that is human genetic data. So for example, GenBank is actually a 3-part international collaboration. Data is submitted from all over the world. And in different parts of the world, there's different regulations for the level of privacy that you're supposed to determine. So for example, in the United States, to have a whole human genome in the database, there's lots of consents and oversights. But we've had submissions from China, which are whole human genomes that just go in. And so we've never actually gotten a ruling on whether it's okay for, you know, should we hide them from Americans because it doesn't follow American ethical policies? Do we make them available to Americans? And at least on that one so far, they've punted.
So, Khadija, do you want to comment at all about this? Unfortunately, even politicians have related sort of genealogy, multi-ethnic origins, as it's become political football sometimes. want to share any thoughts about this?
Yeah, I think I will just kind of underscore what Jim said in that we are going to face kind of different ethical regimes when we're thinking about combining data from different countries, especially when we're thinking about the US, where our own ethical and regulatory frameworks around health data are evolving currently, right? So I was just at a meeting last week at Yale on how do we come up with a ethical and regulatory, framework for EHR data, and talking about data brokers and all of these third parties that are sort of dealing with these health data. And so I think there are going to be different ethical frameworks that we have to deal with when we're thinking about, because as Andy mentioned earlier, these ethical frameworks come from our own cultural values. And so different countries around the world are going to have different frameworks. I know in my research, a lot of US-based scientists have looked very fondly at the UK 500K genome database, right? And for them, not only is it, do they kind of wish that they had the access to that kind of resource, but again, there's a whole different sort of cultural and ethical and regulatory landscape in the UK that even sort of allowed that project to be where it is, not to mention politically, because they also have a nationalized healthcare system, and so that makes sort of linking the electronic health record data with the genomes different than it would be in the US. So there really is sort of a different historical, ethical, cultural genealogies with all of these. So, but to your main question of the policies, they are, and you can chime in here as well, they are in development. There are definitely regulatory holes in HIPAA. I'm personally not as familiar with the sort of international policies, but even governing US-based data, there are holes in a lot of our privacy regulations.
So I'm noticing, unfortunately, that we've reached the end of our allotted time. And I apologize to those who are in line. If you can get them, if you can go fast to the podium, maybe you can get them to stick there and answer your questions. But I want to thank the panel for a wonderfully entertaining and educational. And we are back here. I want to remind you, we are back here at 12:15 p.m.